So I've got two related questions here for us to take a look at. In the first one, I want to see how can we take that exponential equation, 3 to the x equals 7, and convert that to the equivalent logarithmic equation. And on the other one, I want to go the other way around. How can I take a logarithmic equation and convert it into an equivalent exponential equation? So looking at the exponential one first. Right, the first thing I always emphasize, this is going to apply to both of these questions here. In both the exponential and logarithmic versions, the base is always the same. So the base in the exponential equation is 3. So the base in the equivalent logarithmic equation is also going to be 3. Now, to fill in the other two blanks, the logarithm of what equals what, we're just going to take the two parts from the exponential equation, the 3 and the 7, and switch sides. Right? So I'm going to take the 7 from the right-hand side of the exponential equation and move it into the left-hand side of the logarithmic one. And I'm going to do the reverse with the x. And I'm done. 3 to the x power equals 7 is equivalent to the log base 3 of 7 equals x. And one kind of cool thing I want to point out about this, what we've done here, is kind of implicitly, is we've solved that exponential equation. The left side of my logarithmic version is just a number. I mean, it's a kind of a weird number, some strange decimal, but you can go to your calculator, ask you what that logarithm is, and get a numeric value. Okay, so how about the logarithm side? We're really going to do exactly the same thing. The base is going to stay the same, and the other two parts, the x and the 3 in this case, are going to switch sides. Okay, so first, it's a little implied here, right? There isn't an explicit base for this logarithm. Remember, if there isn't a base actually written down there, a little subscript below the log part, then we're talking about the common logarithm, so the base is going to be 10. So that means that in the exponential version, the base is also going to be 10. Right, so all I need to do is fill in the exponent and the number on the right-hand side. And like I said, I'm going to do the exact same thing. The 3 is going to go from the right side of the logarithmic equation to the left side of the exponential one, so it's going to become the exponent. And the x is going to go from the left side of the logarithm to the right side of the exponential version. And again, notice here, we've solved that logarithmic equation. 10 to the third, that's 1,000. It's a number. And so x equals 1,000 would be the equation's solution. So that's how you do this conversion, right? It's very important in a pre-calc, maybe second year algebra class. This is an essential trick. I shouldn't say trick. This is an essential technique to both solving exponential equations and to solving logarithmic equations. So if you like this, if you like this presentation, please don't forget to click on that like button down below as well.